Hey everyone. Our topic for today is about performance appraisal score and normal distribution curve or the bell curve. What I'm gonna do is I'm gonna get the sample of the performance appraisal score, which I'm gonna do now. So what we're going to do to get the sample of the score, I'm gonna do a random between numbers. Okay. So equal sign run between. So click the run between function. Then the argument would be low, comma, and high numbers. These are sample of numbers that we're gonna get. So I'm gonna start with the number 45 as our low numbers, and then I'm gonna get the high numbers, say 75. Okay. Then close it with parenthesis, closing parenthesis, and enter. So we got the 68 are sample numbers with formula run between. So I'm gonna drag it down to get more samples. No need for me to put the name of employees or whatever, because what is important here in our sample is just the numbers or the X numbers, all right? So I'm gonna fix the number, so I'm gonna remove the formula. So just copy it and then copy paste special and values only. So we get values only. Okay, but next thing we're gonna do is I'm gonna, so that we know what is our, the maximum numbers. I'm gonna sort this range. Okay, sort this range. So data tab, then sort range, uh, Z to A. Okay, descending order or the largest to smallest. So our smallest number is 45 and our biggest number is 75. Okay, just like what we want in a random between. Okay, so I'm gonna get the mean number. Okay, the average number of this range. Okay, so the number would be this range, the mean number would be this range. Okay, let's get the formula first. Okay, you're gonna get the average, and the value would be this range. Okay, so we're gonna select this range all the way down to number 45. All right. Although there are several 45 here. Okay, but that's the lowest number that we get from our samples. And then just close it. Then enter. Okay, we don't need too many decimal places, so we're gonna. Okay, actually we don't need decimal places. Just 60 is okay. And then we're gonna get the standard deviation number. Okay. Okay, so that's sigma, standard deviation. Again, okay, what we need here, what we need in our formula is the standard deviation, TDEV. Okay, just click this one, TDEV. Then again, get the range, the sample that we got for our appraisal score. This is supposed to be performance appraisal score of employees. This is what we're getting. So we decide the pass mark, we decide, you know, the majority of the employee who's gotten high score or something like that. Okay, we're going to analyze the observation based on a normal distribution. Okay, so okay, next thing we do is, okay, I'm gonna get the percentile also, and the score to attain, something like that. Okay, Here, maybe I'm gonna start with 60%, okay, 0.6. Then, okay, what I'm gonna do is I'm going to get the X number first. Okay, gonna put it in the middle. Just get the alignment here in the middle, center, right? Then, okay, so the lowest number is 45 and the biggest or the largest number is 75. This is the score, supposedly the score of the performance appraisals held, conducted by perhaps the manager of the department or the company, right? So I'm gonna put it less than 45, maybe 35. Okay, and next one with 36. So I'm gonna copy this down to get all the way up to maybe 85, because the largest is 75. I think, oh, there's too much. Okay, what I'm gonna do is I'm gonna delete from 86. Okay, this one, because we only need our next X number, and this would be our horizontal axis of our bell curve. Then the next thing I'm gonna do is I'm gonna, okay, do the normal distribution. Okay, that would be our normal distribution header, or rather title. And then we're gonna get the norm dot this. Okay, norm dot this one, right? The X would be this one, right? Since I'm gonna copy it down, so that would be a relative reference. Then just comma, and then the mean number would be the one on top, this one, and then, okay, absolute reference F4, then comma, and then standard deviation, the sigma. We got number 9 as our standard deviation of the normal distribution of the observation. So that would be F4. And then the next one would be cumulative. Cumulative is just 0. Okay, as we have learned in the past in our Excel lessons. Okay, then just we get everything right. Okay, just enter. Okay, suggested autofill. Okay, click here. I think it's, yeah, that's what I thought. Okay, we're gonna remove this, all of these zeros. We don't need them. Okay, now we can plot our chart, our bell curve, normal distribution curve. Okay, just select the X number and the normal distribution. The reason why I did not, use the score as our X number, because it will not go to 0, the tail of the curve, right? So because I want to put it lower than the lowest number, 45, I put it 35. Okay, and 85 instead of 75 for the largest number. Then we just click the insert, and then click the chart. It's not working. Okay, it's working now. Okay, okay, um, okay. Uh, See if we can. Yeah, we can read it. I think it's better to get a scatter scatter chart, so that we can easily we can get the, okay, see, we can pinpoint the numbers that's meant to get, right? And it covers, okay, it covers the list that we have, the samples, the normal distribution list. So what I'm gonna do is I'm gonna move this to on sheet. Okay, right? It's on sheet. So what we have is all right. Um, okay, we're gonna get the attain score to attain first, which means I'm gonna be using the norm min v. Okay, just click norm min v, and then x number would be this one, f4, and then comma, and then the mean number would be this one, again f4, then comma, and the last one is the standard deviation of 9. Okay, then f4, then close it, enter. Okay, this is in okay, we need numbers for this, just number. Okay, um all right, remove the zero, rather the decimal places. Okay, 62 be 62. If we decide that we're gonna put 0.5 or 50% of the population, that would be 60 score to attain. Okay, all right. So our average number is 60. Okay, this one, it's right here in the middle, 60, and this would be the zero. Okay, sigma 0, 60, right in the middle, or the median. Okay, median. Then if we go to the right, that would be plus positive 1 sigma, positive 2, positive 3. Okay, going to the left would be positive, rather negative 1, negative 2, negative 3 sigma. All right. And the mean number would be the 60 as what we have here as our mean number. And the sigma is 9. So if we're going to, okay, minus the deviation, standard deviation of 9, 60 minus 9, that would be 51, right? So this would be our observation of the normal distribution. As you can see, they are all equal, left to right, because it is symmetrical, right? Symmetrical. So because of our normal distribution is symmetrical in shape. So this would be 51 right here, minus 9 sigma. Okay, standard deviation from the other side, the positive side is the 60 plus 9. That would be how much? That would be 69. So between 51 right here and right here, 69, that would be our observation area. Okay, the area that we have, the majority, two-third of our normal distribution in our population is right here in between 51. That would be um, okay. That would be 69. All right, minus 51. Okay, right. Okay, that would be our observation. So 61 because um, 60 because the mean is 60 plus 9, or rather 69 rather, sorry. Okay, 69. Okay, and um, 60 minus 9 for the negative sigma, all right, that would be 51. Okay, 60 minus 9 is 51. So minus 51. Okay, our observation is 18. Okay, 18. In terms of the division, okay, it's 18. So between 51 and 69 in this area, because our median is right in the middle, 60. Okay, our mean number, or average, and our standard deviation is 9. Okay, from 0 to positive 1 right here is that would be 34%. Okay. 34.134, I think. Yeah. 34.134%. And for the negative 1, uh, that would be another 34. It's equal. 34.134% for a total of 68.268%. 68. So that would be our majority of our observation, okay, in the normal distribution curve. And on sigma 2, it would be 13.591. 13.591 here in sigma 2. Okay, and on the negative side, that would be 13.591 also. And that the total for that is the 34 plus 34.134% and 13.591 and plus 13.59, because there are two 34.134% and 13.1591%, and total for that is 95.545%. And and the 3 sigma is only about very minimal, 2.14%, okay, on the right side, and 2.14% on the left side. And the total for that is would be 99.73%. Plus the remaining after the 3 sigma that would be going to 0, or the tail end of the curve is 0.135% to the positive, and 0.135% to the negative side on the left side. So the total would would be 99.73%. Okay. So or I would say sorry, that would be 99 rather. 99%, because on the 3 sigma standard deviation is 99.73, but beyond that in the 0 till end, that would be 99 percent, 99.73 rather, or 100%, I would say 100%. Okay, so that would be our normal distribution curve coming from the sample that we have done. So I did not put the names. You no need to put the names of the employees, just the score, because this is the sample data that we want to get our X number, normal distribution, and be able to analyze, okay, all the observation that we have in terms of putting the curve from the normal distribution, be able to get in this area, be able to get the numbers that we want to get in terms of our result, okay, in terms of percentage and the sigma, okay, or the percentage of 1 sigma, 2 sigma, and 3 sigma, okay. So that's it for today's lesson. I hope you like this, and if you do, please don't forget to subscribe and share with your friends and family, and also don't forget to thumbs up if you like it. Until my next video, thank you for watching.